Walk into any modern enterprise today, and you will see an explosion of autonomous AI agents taking over specialized tasks across every department. Most of us understand AI memory through the lens of a consumer tool like ChatGPT. It remembers your name, your writing style, and your previous prompts. But that type of memory is strictly single-player. It exists in isolation, confined entirely to one human interacting with one chat window. The architecture of a modern enterprise, however, is inherently multiplayer. Organizations deploy heterogeneous fleets of specialized agents. You have coding bots, customer service interfaces, and data analysts all running concurrently. Yet these specialized tools do not naturally communicate. They do not share decisions, task states, or past mistakes with one another. Because of this isolation, every single agent essentially starts cold. It begins every interaction with zero institutional context. Stealing enterprise AI currently hits a hard wall of collective amnesia, where high-level intelligence is trapped within isolated, stateless tools. This node map shows a central team surrounded by isolated silos: Cursor, Claude, a PR reviewer, and Jira. The borders are closed. This creates friction. The PR agent flags a bug Cursor already solved. This amnesia compounds costs: hours reprompting, vanished knowledge, and contradictory decisions. While foundational models are capable, they lack the structural coordination required to maintain persistent context across an entire agent ecosystem. To fill this void, a new category of technology is emerging: shared organizational memory infrastructure, or SOMI. SOMI is a system designed to give a unified memory layer to a fleet of AI tools. Think of SOMI as a persistent, vendor-neutral coordination substrate. It sits underneath the entire ecosystem, accessible by any model. It is the required upgrade to transition AI from a collection of stateless tools into a single, coherent organizational intelligence. The industry has recently pushed to standardize how AI agents interact with the world, converging on two major protocols. This animation illustrates the first standard, the Model Context Protocol, or MCP. MCP standardizes how AI models connect to enterprise tools and data sources, acting like a direct pipe for context. The second standard is Google's Agent-to-Agent, or A2A, protocol. A2A manages communication and task delegation directly between different agents. There is an assumption that because these protocols allow agents to share context, the memory problem is solved. But that assumption misses a crucial detail. MCP and A2A dictate how context moves. Neither specifies where that shared organizational memory actually lives. Decades ago, HTTP standardized how web services communicate. It didn't eliminate the need for databases. It created the massive market for them. The same logic applies here. Context packets flow through these communication pipes, but they require a foundational SOMI database layer slotted underneath to catch and store the state. As standardization makes it easier to deploy diverse, multi-vendor agent fleets, the problem of memory fragmentation will accelerate. Standardization acts as the catalyst for a vendor-neutral memory layer, making a persistent storage tier necessary to manage the complexity of multi-agent stacks. The competitive landscape racing to build this infrastructure is active, but highly fragmented. This competitive overlap matrix shows MEM0 as the current leader in developer adoption. However, note the key gap column on the right. MEM0 provides excellent persistent memory, but it remains tied to the individual user context rather than the collective organization. Then we have ZEP and its Graffiti engine. Graffiti is a temporal knowledge graph, a system that tracks both when an event happened and when it was ingested, allowing for complex time-based reasoning. ZEP's limitation is scope. It operates on a single agent basis rather than acting as a cross-harness organizational layer. LEDA takes a different approach, offering stateful agents that curate and edit their own tiered memory. Yet, LEDA creates massive ecosystem lock-in. To use that memory, the agents must run entirely inside the LEDA runtime. Major cloud providers are validating the category, with AWS releasing Agent Core Memory and Microsoft launching Agent 365. But hyperscaler solutions fail the vendor neutrality test. They trap organizational context within a single cloud provider's walled garden. In late 2025, Forrester formally recognized this market as the agent control plane, an oversight and governance layer sitting above the build and orchestration planes. This signals an incoming wave of enterprise budget allocation. Many tools solve adjacent pieces of the puzzle, but none currently deliver a full organizational scope, platform-agnostic shared memory layer. The market demand is validated, and the hyperscaler lock-in is not yet complete. The timing is ideal for a purpose-built, vendor-neutral player. How does an ambitious, organization-wide infrastructure product penetrate the enterprise without a massive top-down sales cycle? This table highlights the highest priority ideal customer profile, software development teams. The wedge use case is specific, providing shared coding memory across agent sessions. The budget potential is substantial. Enterprise engineering teams allocate upwards of $50,000 a year to solve this bottleneck, and the friction is already there. 59% of developers are currently running 3 or more AI coding tools simultaneously. AI coding tools alone represent a $4 billion slice of departmental AI spend, making this the clearest entry point with the highest immediate return. By solving the localized pain of developer amnesia first, a SOMI platform establishes the technical footprint required to eventually capture the memory of the entire organization. This animation illustrates the ultimate defensibility of this infrastructure, the organizational memory graph itself. This data moat compounds. More agents lead to more contributions. That creates richer memory, which makes it instantly more malleable to plug in even more agents. This architecture enables true model portability, allowing an organization to swap underlying AI providers without losing institutional context. You can unplug a major foundational model, replace it with a new competitor, and the new model instantly absorbs the context from the graph. This architecture prevents foundational model providers from holding enterprise context hostage. This image projects the total addressable market for this infrastructure, an estimated $5.9 billion by 2027. That figure is derived from hard buyer counts and contract values, not extrapolated hype. Controlling the vendor-neutral memory layer means owning the persistent context that allows a fragmented fleet of agents to function as a single coherent intelligence.